Welcome everyone to our webinar for spectral data analysis and signal surveillance in aerospace and defense, organized by SAAB RDS, where we will be hosting subject matter expert from Novator Solutions, an expert on signal surveillance, test and validation for the military industry to bring you to the latest technologies in RF, synchronization, and high data rate signal processing. My name is Michael Abdallah, Senior Manager and Aerospace and Defense Sector Leader at SAAB RDS, and I'm your webinar presenter today. I'm based in Saudi Arabia with over than 15 years of engineering research and industrial consultancies. Throughout my career, I have worked on basic to advanced projects with key clients from different sectors of the industry, specialized in research, education, aerospace and defense, and product development. Here I can list some of them, like Prince Sultan Advanced Technology Research Institute, Advanced Electronics Company, King Abdulaziz City for Science and Technology, King Abdullah University of Science and Technology, and KFUPM Innovation Center. From Novator Solutions, we have with us Mr. Lars Hedland, Sales Manager for the Spectral Data Analysis Department at Novator Solutions, based in Stockholm, Sweden. Before starting his position at Novator Solutions, Mr. Hedland worked as the account manager in the aerospace and defense sector in Sweden for a world-leading test and measurement supplier. Today, Mr. Hedland covers the worldwide sales for Novator Solutions and acts as Comment Product Manager. We at SAAB RDS, we deliver cutting-edge sustainable productivity solutions to industry. We bridge the gap between industry and academia, and we provide tailored programs that develop the next generation IT leaders of the Middle East. As part of our vision, we want to be your trusted partner in your technology journey. We are an unconventional technology advisor and solution provider that builds and orchestrates world-class innovation ecosystems to solve complex problems. Our solution methodology is highly differentiated, customer-defined, vendor-agnostic, and value-driven. So we strive to deliver on our commitments with utmost integrity, relentless customer focused, while creating value and social impact. We are a technology consultancy company accompanying the customer in technology investment journey to ensure success. SAAB RDS, in line with his Crown Prince, His Excellency Mr. MBS, and Vision 2030, we leverage our large ecosystem of international partners and stakeholders to enable the Saudi local knowledge-based driven economy market expansion into the aerospace defense sector to support the kingdom in one of the main pillar direction as per NIDLB Industry 3.3.4 chapter. As you all know, the aerospace and defense markets face an era of increasing demand in testing solutions and the need to converge physical and digital worlds through IoT, software-defined radios, and millimeter wave systems. We at SAAB RDS can help you implement reliable testing solutions, design and prototyping of radar, electronic warfare, satellite and spectrum monitoring, embedded software test, aerospace control and dynamics, communication, navigation, and cybersecurity. Additionally, digital transformation is becoming key to success in aerospace and defense. And so many organizations are looking for digital transformation initiatives that will increase operational efficiency and improve mission readiness. We can help you in your digital transformation journey, finding the best solution for your company. We would love to learn more about your challenges, so please feel free to type your questions in the chat box so we can address them at the end. Now, please let me introduce you to Mr. Lars Hedland, who will be covering the following: wideband recorders for radar application and spectrum monitoring, multi-channel receivers. Then he will be showing two demos. The first is demo about HUGIN 200, the multi-channel receiver, and the second will be demo MUNIN 1005 IF, which is the wideband IF recording platform. Lars, the floor is yours.
Thank you, Michael. So, all right. So I hope you can all see my screen. Hi, everyone. My name is Lars Hedlund, and I'm the sales manager at Novato Solution for the Spectral Data Analysis Department. As Michael introduced, this will be my agenda for this presentation, and I will start with a short introduction to Novato Solutions. I will then walk over to the wideband recorders and the multi-channel receivers, and then I will finalize with a live demo on HUGIN 200, and finally we have a video demo on the MUNIN 1005 IF recorder. So, Novato Solutions, we are based in Stockholm, Sweden. We focus mostly on test and measurement, and we now also have products within the spectral data analysis era. We are ISO certified 9001 and 14001. We are also a Gold Alliance partner with NI and have the RF and wireless specialty. This meaning that we have deep knowledge in the products from NI when it comes to RF, the RF platform. We are divided into mainly three different departments. The first department, which the one that I'm representing, is the spectral data analysis. We are doing wideband recording, multi-channel receivers, and we also do customization for the RF and SDR solutions. The second department is control automated test, where we're doing turnkey solutions and also helping out with consulting in LabVIEW and test stand. Mainly this department works in the Nordics and in the Stockholm region. So we have around 15 engineers sitting out on bigger companies like Ericsson, GE Healthcare, and Volvo, to mention some of them. The last one, the last department would be the remote measurement. Remote measurement is mainly sensor stations placed in remote locations to send various environmental information for the industry. A typical example would be to send the water level in dams upstreams, so the mining industry knows what will come to them in a couple of days. Right. Moving on to our wideband recorders. I will go through two of our products, which one of them we also have the video later on. This would be the MUNIN 1005 IF recorder. We based a lot of our solutions on NI platform, and it comes for different reasons. It is COTS product, so we share knowledge with the industry, even if it's very well adjusted for applications within the defense segment. The IF recorder have a gapless high-speed recording of 2 to 600 megahertz of real-time bandwidth. We are flexible in the IF input for this configuration, and also when it comes to the timestamping, our customer use both the PPS signals and GPS timestamping, as well as the clock driven from network. What we'll mention in this product and something that we are quite proud of are the large pre-trigger buffers. This enables the manual control. So if you have, as an operator, you sitting and viewing the spectrum, you can choose to start the recording as soon as you see something pop up in the spectrum, and the recording will start before that signal start to appear, meaning that we will be able to collect the whole scenario for that signal. It also comes with a server application built in, meaning that third-party clients can choose to start operating with the unit and also take care of or take advantage of the pre-trigger buffer. All of the channels are individually configurable. The standard is that we have two 80 megahertz wide EF recorders and one 500 megahertz. Of course, since we are working on a flexible platform, we are able to adapt for different configurations. When it comes to the recording options, we can either have built-in rates, and we can also have the RAID rack, as you see in the picture. For control, we have clients that are showing the spectrum. We also have a client showing the RTSA, so spectrogram and persistence display. For the RTSA, as of today, we have a 70 megahertz of real-time bandwidth. Again, the architecture of this one is meant for be as an integrated part to a bigger solution. It is an EF recorder, so an RF front end would probably be something that customers are in need of. That said, it's not always the case. So both for replay and playback, there are options to have the playback option as well. Moving on to the next recorder, and this will be a RF recorder, is our HUGIN, or sorry, ODEN 3001. We call it an intelligent recorder because we have put some intelligence behind the recording part, and I will walk you through this. The RF front end, which would be 16 kilohertz to 14 gigahertz or 26.5 gigahertz. We have the instantaneous bandwidth of 200 megahertz or 765 megahertz. And depending on where you are in the spectrum, this will differ. So if you go lower than 3.6 gigahertz, we can't have the option of 765. So the 765 is above 3.6 gigahertz. So coming to the interesting part, the recording options. So we put down some intelligence making use of a high resolution frequency mask on the FPGA. To this, we have different bins for each of the frequencies, meaning that we can get information and we can use that information down at FPGA to triggering recordings. For this, we have a recording editor that you can put certain regions and set certain rules for these regions. Meaning that if we see something, an energy pops up, we can start to record either that specific channel where you see the energy, or we start recording the full region or the full bandwidth of the whole spectrum. And recording meaning that we record IQ data and not the spectrum itself. To this, depending on the width of the full spectrum, we can have 128 or 1024 individual digital down converters for this recording. So for example, I hope you can see my mouse here. In this case, we have a region where we have a certain rule, and as soon as energy top the frequency mask, we can start to record that specific channel for it, the IQ data for that specific channel, or we can choose to record the full region. I would recommend, if you are more interested into this, please give us a heads up through Mikael here, or and we can have a live demo on this unit. Going back there. So, as you can see, we have a live spectrum view, and we also have the waterfall view. We also have, as soon as we start the recordings, listing of all the recordings that have been made. With this, we can choose to open up the specific recorded signal, and we can view that in the viewer, and we can replay that specific in software and see what we actually got. Again, if you're interested in this one, please let us know, and then we show you a live demo on this unit. Sorry, active. So moving over to the multi-channel receivers. I will start with a short introduction to some of our IP that we are using within this one, and also in ODEN for that sake. We have multi-channel, we call this a channelizer. It is in practical multiple DDCs that are flexible in the sense that they are individual. In this case, we have either one or several wideband IQ streams coming into the IP. And the picture shows basically that we have a wide and we have several signals on that spectrum. Looking at that spectrum, we can choose to place specific narrow channels. And with this, we choose to do digital down conversion for each individual channel, meaning that we get a stream of IQ data for that specific channel. We can independently channelize each specific channel, and we can also set configuration for all of this in real time during runtime. Meaning that setting the center frequency, the sampling rate, gain, and certain filters. And depending on which platform we are using, we also have in those FPGAs analog demodulation for each channel. And that can be set for each individual channel. In total, we get up to 1024 channels per FPGA. So what have we done with this? Well, when it comes to comment, it's always interesting to capture as much signals as possible. Our flagship is HUGIN 2000, which is a multi-channel receiver, reaching from 20 megahertz to 26.5 gigahertz. It comes with either 1 or 2 tuners, up to 200 megahertz of real-time bandwidth. And what you get is 1048 narrowband channels streamed out to your network or to your clients, more or less. An option is our smaller footprint version, which is based on the USRP. That comes with 10 to 6 gigahertz of frequency range, and you have 4 tuners of 80 megahertz real-time bandwidth. With this, we have 512 narrowband channels as output, or 265 narrowband channels if you like to have the demodulation part on the platform. Since we only have one FPGA to work with, there are 2 options. So we rely on NI's platform. We have a really good high-performance RF front end. And for the HUGIN 2000 options of 50 megahertz with a filtering bank, it's also something that customers appreciate quite a lot. But it also comes with a 200 megahertz. We have the server and client architecture. The same as I explained on the ODEN, we tend to see this as a component in a bigger architecture. On the controller itself, on HUGIN 200 or on the HUGIN 2000, there are a server application making sure that all the configuration of the channels stay put, and the clients only need to take care of sending commands on how this configuration should look like. And that is sent through the TCP/IP commands. I will actually go through that a little bit more later on. And again, all these channels that we get are all individually configurable during runtime. And I think this is the main part it's good to mention. Working with this and working with different clients connected to the same receiver, it's highly effective when it comes to a bigger installation. So one example of that as a bigger installation is how we like to see this and how it works today at our customers. Imagine that we have several emitters out in the field. We have several sensor sites. It could be fixed installations at land, or even in vehicles or bigger vehicles like boats and airplanes. We hook them up into a network where we have different operator sites. So one of these operator sites could be the workstation for a operator working at the boat, for example, or the bigger operator sites, which is more sensoralized, where you have more of the analytic software and so on. The advantage of having a remote access to these sensors would be that we can access them and do system configuration and control, for example, controlling antennas and so on. And we also have the option of installing software updates. So for example, if the system sits on a boat, it's not always the case that the boat will be at the dock all the time. So the access to doing software updates if needed, then that could be done remotely. We also have the option of doing more analytic part to find out more about our emitters that we see out in the field. And typical example of that would be to do TDOA, direction finding, with the differential of time of arrival differential between these sites. Another big advantage, as mentioned before, it's that operators and experts can work simultaneously with autonomous software. So for example, operator sits looking at the spectrum, listen in directly on different emitters out in the field. At the same time, autonomous software doing tasking functions can use the same sensor, in this case the receiver, to work with other channels. And this is all done with a server and also the advantage of having many channels. So not be able or restricted with a certain amount of channels, instead having thousands at each sensor site, enables all of these to work together. And again, the built-in server enables the control of all the channels. So even if a client connects to the server, it can get information where the channels are put at the moment, and can also send commands to get access and get channel streams for itself, as an example. Another good example of how we use the HUGIN 200 in this case would be more in the industry. So in this example, we have a challenge from the customer that they having transmitters, FM transmitters, sending sensor data from a turbine under test. And the challenge was to collect all of these sensor data for the later inline processing. And of course, as low cost per signal as possible. So traditionally, what they were using was several radios to get all of this sensor data. So typically how it looks is that you have several sensors sitting on different parts of the turbine, and they are transmitting with FM frequencies to the test equipment. What we can do then with HUGIN 200 is that we receive all of these individual channels and get them back to the analytic software using at the customer side. The advantage here is also that during runtime, the operator can tune each individual channel during runtime. So you don't need to stop the whole test if a channel seems to be a little bit adjust. And it was really a success for this customer to work with this as the receiver, instead of having hundreds of individual radios. Right. So moving into the more of the system integration, what we use is a controller running Windows. In this case, we moved over to Windows 10 for most of our products. And on that, we have a server application. The server application runs logs and also show how events occur. So if there are several clients connected, it keeps track on that. But the most important thing is it configure and keep track of all the settings down to the hardware itself. And how it typically works is that we have JSON coded commands sent to the controller over TCP/IP. So this is a typical example of how a channel, the client requests the channel, the center frequency of one of the tuners. And the server responds with saying that this is the current setting for this specific channel. So this could be a client just connected to the server and asking, where are the channels put right now? Okay, perfect, then I know. From that, I will move into showing a demo of HUGIN 200. For this demo, I have a remote computer, so I will just log into the remote computer and show you. I will run the server and the clients on the same computer in this case. As you can see on the picture, there are two lines. One of them is used for sending commands and controlling of the receiver hardware. The second one is for streaming the individual channels back to the clients. So in other cases, the client could be a separate computer that receives all the channels. We hook this up to an antenna, so it's actually connected to an antenna here up on the roof at the building. So we will be able to listen into some air traffic and run radios. And I will swap to that. And of course, it's a demo, so I hope everything will work. What you see now on the screen is the server application or the server software. The server software have two logs. We have the event log and we have the command log. This software can be run as a GUI as it is now, or it can be started as a service in Windows. So it will just be as a service icon down at the right corner. In the server, you can do settings for or configurations for all for the hardware and also the network operations. So setting IPs and so on for the server. In the event log, we show how things are going with the server, if there is something wrong with the hardware and so. In the command log, we see all the logs that have been sent, all the commands that have been sent to the server, and also the response from the server. I will now open up the client that we call configuration. In this case, we are on the 4-tuner hardware, so we will have 4 tuners. And for this example, we have the center frequency of tuner 1 at 120 megahertz. And this is showing the spectrum. And also we can see all the channels with all its configurations. I will show you later where we change the channels and how that works. So this is one of the clients, the configuration part. We also have a client for receiving the channels that we call NC channel or HUGIN channel. And for this example, I have chosen to have a certain amount of channels. And here we can see the spectrum of each of these channels. As for an example, at tuner 1 and channel 4, I have put a channel at an AM demodulation. And this specific frequency is for the Arlanda airport. So it's basically I am broadcasting off from the tower. And I will see now, I hope that you will hear this. It's just sending some. Right. So this is one of the channels. And to be able to change all of this, we can either just set a new frequency, or I can open up. I will do so with a batch. So in this case, I will have all of these channels that we are able to change. So in this case, I have the 256 version. So I have the demodulation done on the FPGA. I have settings for which tuner each individual channel could be set. So I can choose to either have all the channels set to one of the tuners, or I can choose to set some of the channels to tuner 1 or tuner 2, or yeah, up to 4. For each individual channel, as you see, we can set center frequency, bandwidth, which type of demodulation, or if we like to have IQ. We can even set the multicast IP for that specific end port for that specific channel, meaning that if you have several clients in your network, you can stream them to specific clients. So for example, if I like to choose, or if I like to change one of the channel's center frequencies, let's change that to 107.5. So this is a round radio megahertz. And I just stop this one or click it and accept the changes. We can see now at the bottom that commands are sent to the server. And we can also see that the frequency here have changed. So this is channel 3, and I will activate that so we can also have that into the channel client, and then we can start listen. So bear with me. I have no idea what they are broadcasting. We can probably turn down the volume. It's a round radio, so yeah, some music playing. So basically what we can do here is that we can have as many channels as we like, and we can have several clients connecting to it, getting all the needed information. As you also can see, we get the level from each of the tuners. Remember now that I have not calibrated this unit before this demo, so don't take the numbers for granted. Good, and that concludes that demo. All right, I will now step over to the second demo, which will be demoing the MUNIN IF recorder. In this case, I will have a video shown by my colleague, Karsten Mantola. And it's good to remember that in this case, we also have a server running on the hardware itself, and we have clients that could be run on different computers. The server contains the information on the buffering, and the client shows the real-time spectrum and also the ability to stop and play back the recordings that we made. I will let Karsten tell you more.
Welcome to Novato Solutions. In this short video, we will introduce MUNIN 1005 IF, our latest wideband IF recorder. MUNIN is the ideal wideband recorder when you need to analyze the spectrum offline for maximum analysis coverage, or to perform repeatable lab tests, which shortens the time to market of your products. MUNIN enables gapless recording of wideband and narrowband signals from 2 to 600 MHz instantaneous bandwidth. Standard configurations include 2 narrowband IF inputs from 2 to 70 MHz and 1 600 MHz wideband IF input. The server-client architecture separates all time-critical tasks, including signal processing, data buffering, and streaming to disk, from non-time-critical configuration and control tasks. The built-in ring buffer is used as a large pre-trigger buffer to capture all signals from the beginning. during the recording, it is used as a circular buffer, which ensures gapless recording with data rates of multiple gigabytes per second. You can use any third-party application software of your choice to continuously analyze the spectrum and start the recording remotely. The real-time spectrum monitoring option is ideal for manual spectrum surveillance. The RTSA client comes with spectrum, persistence, and waterfall displays. With the client, you can capture rare or short events on the screen and start the recording manually. Thanks to the large pre-trigger buffer, the recorder captures the spectrum from the beginning without losing data, no matter whether latency is introduced by starting the recording manually or remotely via a third-party application. MUNIN supports out-of-the-box remote operations. Besides MUNIN server, it ships with MUNIN client, which lets you configure and control the recorder, and it lets you play back the recorded files. The enterprise storage options start at 4 TB for in-chassis RAID. External RAID solutions are ranging from 24 to 184 TB. With a fully loaded configuration, it is possible to record a single 70 MHz signal for over 160 hours. To learn more about MUNIN Wideband IF recorder, please take a moment and visit our website or contact us directly via email or phone to discuss your project. Thank you.
Right, thank you, Karsten. And that concludes my part. Think just to get an that. So I'm done. Over to you, Michael.
Thank you, Lars. Now let's move into the Q&A sessions. So if you can write down your question in the chat box so we can answer all your questions. Also, we have, Lars, one question from Mr. Muhammad. He's saying about the maximum frequency band that your recorders can attain.
So the maximum frequency range would be up to 26.5 gigahertz.
Okay, so I guess this is based on the NI-PXI, right?
Yes.
Okay, excellent. People who's attending, can you please let us know if you have any additional question so we can address now the answers? So Lars, I have a question regarding the development. So usually are you getting the customer involved to get all the requirements or these solutions are ready-made?
So the solutions are presented now. They are already made and they have been around for several years. So the HUGIN 2000 have been on the market for, I think it's almost, it's 7 years or so. And in some of these, we collaborate with the customer at first to get the requirements down. And then if it is something that we like to continue working on, then we finalize it and making it better as a solution so we can productify it as a product. I would say that most of the time it starts with an idea from a customer and we involve it into a product. But the ones that I presented today, they are all released as products and gone through testing and testing even out in field at customer sites.
Okay,
What-
excellent, excellent. Thank you, Lars. So I guess we are done with the questions. We have as well some requests regarding if we can share the video or the presentation. Yeah, sure. We will share it at the end. You will receive an email with it, basically about the recording of these sessions.
I have a
Okay.
question, if you don't mind.
Go ahead, Ralph.
Yes, first of all, thank you very much for this nice presentation. I have a question regarding the demo that you showed, which is amazing. It's whenever you chose the FM frequencies, is it something that you have tried as well for the GSM? And have you included some special decryptor in your solutions, or this is something that in your plan for the future? Thank you.
Yes, and a good answer to that. Maybe I can how to do that. For the demodulation part, we have the analog demodulation done on the FPGA. Coming to the more, let's say, digital demodulation and decryption, we collaborate with a Finnish company called Combitech, and they having a software called Sandra, and that software is used for comment monitoring. Within that software, all of the mention when it comes to recording specific channels or demodulation in terms of digital demodulation and analysis in general, it's done in that. I had some more information on a web page on that, but as for now, we're looking into how to make it more available to have more demodulators and decoders into our software as well. But so far, we only have the analog part, so AM, FM, CV signal or SSB. Did it answer?
Yes, thank you so much. What about millimeter wave? Because you mentioned earlier that we have some ready-made system up to 26.5 gigahertz on the PXI, on the NI PXI. Is it something that we can also extend it to the millimeter wave size up to 70 gigahertz? And I guess there is one more question about the support of third-party hardware other than NI, right?
Mm.
So can you please let us know about that?
Yes, so we have in some cases used external receivers as well. So if they doing V249, for example, and sending that in digital format, we have tested that for customers' sake as pilot projects, getting the IQ data stream digitally and then into the PXI system, and then worked from there, so to say. The second part, extend. Yeah, I mean, we know the NI platform very well, and working with, for example, the VSTs that have the millimeter wave extension, that shouldn't be a big thing. We haven't tested it, but I don't see it as a problem to include that, of course.
Okay, excellent. So yeah, so they were asking if this software support other hardware than NI, like Keysight or Rode and Schwartz. So what do you think?
Yeah, so the main part of the software is a FPGA IP, right? So supporting other units, we can support IQ data streams from others. So we tried with the Leonardo DRS, for example, getting the IQ data stream through SFP Plus ports. And then used it together with a channelizer. That is fully probable, and in some cases NI doesn't have the right RF equipment, so that are the units that we're using. Even at the PXI platform, Keysight have some generators that we also tested for actually playback of signals. So we don't work exclusively with NI. That is the truth.
Okay, excellent. Also, we have a question. Is it possible to regenerate the recorded IQ signal?
Depending on which platform that is mentioned, maybe. What we have for MUNIN, for example, the IF recorder, we have the option of replaying or regenerating signals that have been recorded, even at the platform today. So there are IF TX. TX, not RX. So TX versions as well. So we have worked with them and are able to do regenerating. And we are working with the customer right now actually to do that on MUNIN platform.
Okay.
So that's the IF. On the RF side, we are streaming out the channels. I know that I got these questions before. Is it possible to, in terms of like stitching all of the individual channels together and then broadcast them as a wideband output, so to say? We have thought about it. There are some complications with doing that. So I don't know the level of quality when it comes to that, because when you are stitching several narrowband channels together to make a wideband, you get a lot of images and so on. So it's a little bit more complicated.
Okay, thank you, Lars. I guess we have no additional questions. Okay, excellent. So with this, we are closing the Q&A session. We hope we could cover the majority of your questions. And in case you have more, please contact me directly. So we are here to serve you. Our event reached its end. Thank you for all your questions, feedback, and most importantly, thank you for your time. The recording of this webinar will be available to attendees soon. You will receive an email with it. We were honored to have you in our event, and please reach out to me by email or by phone for any further questions. We would be very happy to hear your problems and provide you the right solution. Have a great day. Thank you all.
Thank you very much, everyone.